Good day, everyone. So today we shall be looking at a concept in basic technology titled energy and power. This concept will make us understand how electricity help us, how electricity are produced, and also the concept of motion. All right. So let's dive into this. Let's start with what energy is. All right. What is energy? Energy is the ability to do work. So when you are able to do work, then we say that you have energy. We can't see or touch energy. We can only observe the effect. Okay? So when you carry a load, we can only observe that you are carrying a load. But what makes you to carry that load is the energy in you. All right? So we can't see it, neither can we touch it, but we can what? Observe it. And energy is measured in joules. In other words, the unit of energy is joule. Sometimes we also measure it in kilojoule by symbol kj, in joule by symbol is j. Energy is the foundation of all physical processes. Any process at all in the physical requires energy. Is it waking up from your bed? You need energy to rise up. Even communicating, you need energy to talk. So that leads us to multiple forms of energy. We have heat energy, we have chemical energy, we have kinetic energy, we have electrical energy, and so on and so forth. So energy can come in different forms. All right. Well, can energy be created? No. Can it be destroyed? No. So this is conservation principle. You can't create energy, neither can you destroy energy. Rather, energy can only be converted from one form to the other. Okay, you can convert energy from heat energy to chemical energy, from chemical energy to heat energy, kinetic to chemical, and so on and so forth. It just exists. No one creates energy, no one can destroy energy. When you think you are destroying energy, you're actually converting it to another form. Okay, so it's a transforming physical quantity and transform from electrical to heat, chemical to heat, and so on and so forth. All right, I will say that. Can we move on to understanding what power is? We have already said that energy is the ability to do work. But when we are now timing the work we do, then we say that we are exhibiting power. Power simply means the rate at which work is done or energy is consumed. So when you work and you time your working, then the whole process is known as what? Power. This is how we define power in science. Okay, the rate at which work is done. That is the time rate at which work is done. Okay, and okay. So this is just a clock showing how power is obtained. Okay, you can call it a watt meter. Okay, the instrument for measuring power. Okay, now we can say that power can come in different forms too. Okay, it can come as electrical power, it can come as mechanical power. For electrical power, it enables us to know the rate at which our electrical energy is consumed. The light that we use today, the laptop we use, our phones, they consume energy. They consume electrical energy. Now, the time at which they consume this energy together is known as what? Electrical power. The time rate at which this energy is consumed is known as what? The electrical power. And electrical power is measured in watts. And remember, I said that the watt meter is the instrument for measuring power as well. Then we also have mechanical power. This one tells us the rate at which machines perform work. Its own formula is energy over time. Generally, power, the formula for power is energy over time, or we can say energy divided by time. Since we say work is also power is also the rate at which work is done, we can also say that this formula for power could be work divided by time. So power has two formula. One is power equals to energy over time, and when you replace this energy with work, you can also say power equals work over time. All right. So I will say that we go straight to one of the forms of energy that we have, and that is heat energy. Heat energy, we have said earlier that we cannot see energy, we can only observe it, we cannot touch it, we can only observe it. Now, heat energy, have you ever seen heat before? No, but you can feel it, right? Yes, that is what energy is. But then we can know the source of heat energy. Heat energy are usually from burning fuel. You can see burning fuel like firewood, coal, gas, kerosene, and so on. Anything that can generate heat are the source of what? Heat energy. So heat energy actually raises temperature of objects. If an object is, let's say, an object is 20 degrees Celsius hot before, by the time heat energy is applied, it might be increased to maybe 50 degrees Celsius. So the effect of heat energy is that it raises the temperature of an object from a lower temperature to higher temperature. And we use heat energy primarily for cooking and warming. Our gas cooker generates heat, our hot plate generates heat. So, and we use this to cook. Generally, we use heat energy for what? For cooking and warming our food. All right. So we can also talk about another form of energy, and that is mechanical energy. This energy actually deals with movement. So it's actually energy of motion, and it's of two types. We have the kinetic energy and the potential energy. For kinetic energy is energy of moving objects. For example, you could see this hammer now hitting this nail. So when you are striking this nail with this hammer, because of the movement of the hammer, we say that the hammer is exhibiting what? Kinetic energy. On the other hand, we have the potential energies. These two are other mechanical energy. The potential energy is actually energy from position. Look at this object here. The energy of this object at higher position is higher than its energy at lower position. So potential energy is energy to the position. An object at the lower position has a lower energy, like I said before, than that of object at higher position. All right. Now, having known that we have mechanical energy, we have heat energy, let's talk about other forms of energy too. We have the electrical energy, we have chemical, and we have the sound energy. Electrical energy actually comes from our electric appliances like the fan, radios, televisions, and iron. Okay, so this energy actually are the one that powers all these electrical appliances. Without electrical energy, our fans cannot turn. They are the one that powers our fans or any electrical appliance at all, our radio, our phones. So that is what electrical energy does for us, just like heat energy helps us to cook our food, generate heat. The next one is chemical energy. The chemical energy helps us in storage of our food. Okay, okay, such as kerosene. Kerosene is a chemical. Now, you use kerosene to cook actually. So if you don't cook your food or with this chemical to generate heat, then definitely your food might get spoiled. All right. Now, wood itself is chemical energy because it forms a chemical inside it that it generates the heat that we call the firewood. And then the animal dungs also that the poo of animals are also chemical energy. This energy also are used as a manure, okay, in feeding the plant in our soil, okay, in fertilizing our soil. Now we have food chemical energy, okay, that help us to produce the muscular energy that we have. The food that we eat, they are chemical and they generate chemical energy. When we consume this food, it is converted into our own muscular energy that make us to move from one form to the other. So chemical energy actually plays a lot of role in our lives. And the next one is the sound energy. Of course, from the word sound. So sound energy occurs when there is vibration in the air. Okay, the vibration of the air, okay, is what brings sound into our ear. Okay, so if there is no sound energy, I'll tell you, even as I'm talking to you right now, there is no way you could have heard what I'm saying. Because as I make my sound, the air that I'm speaking into is vibrated and it moves, it carries my words into the hearer. So sound energy help us to hear ourselves. So because of the vibration that it creates, okay, without vibration of air, there will not be sound. In other words, without air, sound energy cannot even be transmitted. All right. So I will say this. Can we now look at two more forms of energy? We have the solar energy, which is the most popular one today. The solar energy comes from the sun ray. The word solar is another name for sun. All right. So the solar energy comes from the sun ray, and we have the panel. We can see a panel like this. Some of you will have seen it in some houses, or maybe we might even have it in our houses. No, this is a solar panel. It receives the sun ray, and then the sun ray that you receive is the solar energy itself. And then by the time you receive it, it converts it into electrical energy that we use in our various homes. Okay. Aside from the solar panel that make it of the solar sun ray, the solar energy also is used to dry our clothes. That's the sunlight. We use the sunlight to dry our clothes, and then the plant also make use of the sunlight to produce their fruit through photosynthesis, and the sun ray help in sustaining all life on earth. Of course, the solar energy also help in generating heat. All right. So aside from the solar energy, we also have the nuclear energy. The nuclear energy help us in generating electricity. In other words, it can be converted to electricity, okay, using nuclear power station. All right. They are produced from some substances too that might be dangerous to us, okay, and that's why it is rarely used. They are produced from some substance, chemical substances that might be dangerous to man, but not all. Okay, because we use them in producing nuclear power station, which generate electricity. But the content inside this nuclear power station may be very dangerous to our health if it explodes. However, we still use the nuclear power station in generating electricity. So the major area of application of nuclear energy is in the nuclear power station. Okay, so we can now talk about the relationship between work and energy. What is the relationship? Now, when we talk about work, we say that work is done when energy is used to move an object through a distance. So the only time we say that you have worked in science is when energy is used. And when energy is used, there must be distance covered. Like this, look at this man here trying to run. If this man does not move an inch from one point to another point here, it does not work because he has not covered a particular distance. So we can only say that work is done when energy is used and distance is covered. And that leads us to the formula for work. Therefore, work formula GW is equal to force times distance. Okay? Work formula is what? Force times distance. And the force itself is the product of the mass of that person or the object and G. That we call that G, acceleration to gravity. The work done by formula is force times distance because you need energy and you need distance to cover. Okay, and the unit of work is Newton meter. Okay, the unit of work is Newton meter or joule. So work has two units. Either you express a Newton meter or joules. You can write Nm by symbol or capital G. All right. So it is known as, it has Newton meter as unit because force is measured in Newton and distance is measured in meters. So that's the unit. Okay. So that's it. Work is force times distance. All right. Now energy too is taken to be force times distance. Since if you must work, you must use energy. If you must cover a particular distance, you must use energy to do that. So we can now say that work and energy have the same formula. Work is force times distance. Energy is also force times distance. And work is measured in joule or Newton meter, while energy is measured in joule or Newton meters. All right. So now let's talk about power. Power itself, like I said earlier, we said that power is the time rate at which work is done or energy is used. So by formula, let me remind us again that by formula, power is what? Work over time or energy over time. Now look at this question here. It says, a man lifts 50 kilograms from ground to 6-meter height in 5 seconds. Take G to be equals to 9.8 meters per second squared. Now, this G in science is a constant known as acceleration due to gravity. It's a constant, and we must know that. So we usually use this constant to change mass to force. Okay, if you want to change mass to force, we use that constant. Okay, so now from here we have it as work done. The work done by the man is force times distance, and force now, I've said force simply is mass of the man times this G. Let's have to change mass to force. We multiply the mass by this G value. So our force here is 50 times 9.8. Then multiply by the distance. The man covered the distance of 6 meters. So multiply by 6. Alright, so that's it. And the product of all of this will give us 2,940 joule. Or if you want to convert it to kilojoule, you divide it by 1,000, and that will give us 2.940 kilojoule or 2.94 kilojoule. Okay? But for power, if you have to calculate the power that the man expended, power formula is work done divided by time. Remember that we have calculated the work done by the man here to be 2,940 joule. So we bring it here. Our work is 2,940 joule divided by the time it took the man, okay, to cover that height, which is 5 seconds, so divided by 5. And then the value of 2,940 divided by 5 will give us 588. The unit of power is watt, so watt or 588 W, capital W. Alright, so that's how to calculate power or work done, okay, by an object or a body. Now, what is our key takeaway here? Number one, we have said that energy is the ability to do work, and it exists in multiple forms and can be transformed between themselves continuously. We also look at power being the rate at which energy is consumed or at which work is done. Okay, it is work done divided by time taken by formula, and it is measured in watts. Lastly, we look at the 7 major energy form power in our world. Okay, we are able to say that energy can be changed from different forms, from heat energy to mechanical to electrical to chemical to sound to solar and nuclear energy. All right, so we shall be drawing the curtain here today. I hope you have learned something. Thank you for watching, and bye for now.